What is a transistor?
A transistor is a type of semiconductor device that is fundamentally used for amplifying or switching electronic signals and electrical power. It is the basic building block of modern electronic devices and is commonly used in virtually all electronic equipment. Transistors are composed of 3 layers of semiconductor material, each capable of carrying a current.
Hi everyone, welcome back to Xcoding with Alvian. In this video, we're going to build an AI voice assistant application using OpenAI APIs, such as the latest GPT4 large language model and the Whisper API to convert audio speech to text. And then we're going to also use the new TTS API to convert text to speech. And we're going to use SwiftUI to build this app. So basically, our app will support 3 platforms from iOS, macOS, and Apple Vision Pro using just one code base. Now, let me show you the demo of the application running on the 3 supported platforms, macOS, iPhone, and Apple Vision Pro. Let's begin from the macOS application here. So as you can see, we have this microphone recording button, which will start to capture user microphone when we tap. And here we have the segmented picker to select the voice, which will be used by the ChatGPT response. Okay, and let me just tap this and record from my question. Who are the founding members of OpenAI?
OpenAI was founded by Elon Musk, Sam Altman, Ilya Sutskever, Greg Brockman, John Schulman, and Wojciech Zaremba in December 2015.
Wow, nice. Now let me try to prompt using my iPhone here. Who are the founding members of Apple Inc.?
The founding members of Apple Inc. are Steve Jobs, Steve Wozniak, and Ronald Wayne.
Oh, nice, nice. And finally, let's try to prompt using the Apple Vision Pro simulator. Okay, so here, let's just select this echo. And one thing that we can ask the AI to just use our own language. In this case, let me ask using Bahasa Indonesia. Bagaimana menjaga kesehatan tubuh? Oh, nice.
Makan makanan bergizi. Makanan yang Anda konsumsi
And the
setiap
response
hari
is
harus
now in
seimbang dengan
Bahasa
karbohidrat,
Indonesia.
protein, lemak, vitamin, dan mineral.
This is
Dua,
amazing,
rajin
right?
berolahraga. Olahraga minimal 30 menit sehari dapat membantu mencegah berbagai macam penyakit seperti obesitas, jantung, diabetes, dan tekanan darah tinggi.
Okay, let me just stop this using this
Tidur
button
selama
to
7-9
cancel.
jam setiap.
Okay, and that's the demo of the application AI voice assistant that we are going to build. We're going to utilize all the OpenAI APIs, such as GPT4 model, Whisper API to convert audio to text, and then we're going to use the new TTS API to convert text to speech from the GPT response. Okay, and that's it. Now let's begin. Let me just close all of this window. Let's begin by creating a new Xcode project. Select multi-platform tab and then select app. Click next. Give it the name of your product. I'm going to give the name of XCAAI Assistant. And then click next. Save it anywhere you want. Okay. So this is a template for the SwiftUI multi-platform project. Now let's go to the project setting. If you see in here, we have 3 destinations, iPhone, iPad, and Mac. Now let's add Apple Vision Pro. Okay, this one, Apple Vision, and enable destination support. Okay, so now we support iPhone, iPad, Mac, and Apple Vision. Those are native applications. Okay, for Mac we are not using Catalyst, and Apple Vision app itself will also be native. Okay, and for the minimum deployments, let's just set 17 for iOS, for macOS 14, and visionOS it will be 1.0. Okay, next one, for the iPhone orientation, let's just make it an portrait only application. Next one is, let's go to the signing and capabilities, and here for the Mac application sandbox, we need to enable this outgoing for the network to make an international internet connection outgoing to the OpenAI APIs. And then for the hardware, check this audio input. Okay, and next one, let's go to the this project settings in here, and then for the package dependency, click here. We're going to add two new dependencies. The first one will be this SiriWaveView to enable the Siri waveform view. Okay, so I'll provide the link to this GitHub repo at the description below as well. Okay, let's add this package. Make sure it is added to the XCAAI assistant target. Okay, and the second one is the OpenAI client. I'll provide the link to this repo as well, XCAOpenAIClient. Okay, just add this. So this OpenAI client itself is using the Swift Open API generator to generate the APIs and types from a Open API based Swagger YAML file. Okay, add package. This one will take more time because it has many dependencies if you see in here. So this is the XCA OpenAI client. In here, if you see in the sources, we have the YAML file containing all the endpoints. And here I also create a public API to help us making an API call. Just ignore of this error, it will go away after we build the app. Okay, so we have the prompt ChatGPT, can pass the prompt, the model, the previous conversations, assistant prompt, generate speech, which we can use to basically convert a text into an audio data. Okay, and here one is the generate audio transcription, basically which can use to convert the audio data into text. Okay, so this is the OpenAI client that we are going to use. Next one, let's go back to the project settings in here, select the target and select this info tab. In here, we need to add a new key. Okay, it will be privacy, microphone, usage description. We need this to basically request access to the user input for recording their voice. Okay, so we need to give the text that will be shown to user. Talk with AI assistant. You can provide any message that you want. Okay, and that's it for our project settings. Now we can start to code. First, let's go to this XCA assistant app. Okay, so let me make the text a bit bigger. So in here, first let's add a limit the frame of our window for Mac OS target. Okay, so let's add this conditional macro. If the OS is Mac OS, okay, I'm going to limit the size of the window by adding this frame modifier and then pass the width for to be 400 by 400. Okay, for the width and height. Okay, and also in here at the window group, I'm going to also add a if OS is macOS, the macro. So if the OS is macOS, I'm going to add this window style. I'm going to pass hidden title bar. not going to show the title bar. And I'm going to also limit the resizability for this window to the content size. So the user won't be able to change the size of the window. Okay, it will be just 400 by 400. And also for the Vision OS, I'm going to also add else if OS is Vision OS. Okay, for Vision OS, I also want to limit the size of the window, volumetric window, the default one. So I'm going to pass. So I'm going to pass the width to be 0.4, height 0.4, and the depth I'm just going to make it flat, passing 0, and it's going to be in meters for the unit. Okay, and also just limit the resizability to content size. Okay, now let's try to build first. So for this window shows up in your machine. It means this for the SwiftUI, it has this plugin that will generate the code, right? So just click this trust and enable all, and then try to build again. So the first time that you build this app, it's going to take a bit longer because it will generate the OpenAI runtime for the OpenAI YAML file. It will create all the client and types for us. Okay, the build succeeded. Now let's just so this XCAOpenAIClient app, this is finished. Now let's just go in here, Project Navigator, and let's create a new file called models. So let's create several models to help us represent the state of our application. The first one is going to be the voice selection. Okay, I'm going to give a name of the enum voice type. Going to make this to be an enum string and make this codable, hashable, sendable, and also case iterable. Okay, so the user can select the voice from the picker. So in here, I'm going to have alloy, echo. So these cases are from the text to speech API from OpenAPI. Okay, it has this alloy, echo, fable, and onyx, case nova, and finally shimmer. So probably in the future they will add more voice type, but I'm not sure. But this is the current one that they are supporting. Okay. And next one is an enum to present state of the UI. It's going to be voice chat state. So we're going to have several one. The first one is idle, and the app launch initially will be idle, and then recording speech when the user tap on the recording button, and third one is going to be processing speech when we make a call to OpenAI API, convert the speech to text, prompting GPT4, and also converting the GPT4 response to speech data. Okay, and next one is going to be playing speech, and finally we're going to also have an error case in case we encounter an error in one of the situation. Okay, so these are the models for this application. It's going to be just a very simple application actually. And next one, let's create a new file again. We're going to create a view model. We only have one single view model for this application. First one, let's import AV Foundation. We're going to use this for the AV audio recorder and AV audio player to record and play audio in our app. And next one, we're going to use this new observation framework, and we're going to use the XCAOpenAIClient to communicate with the OpenAI APIs. Now let's use this macro observable, and then the correct class ViewModel, and make this conform to NS object. Okay, and let's declare the client OpenAI client. You need to grab the API key from your OpenAI account. So here, platform.openai.com, select this API keys and then provide your own secret key. I'm going to use my own API key in here, but for sure, this key will be revoked when I publish this video. Okay, so you won't be able to use this. And next one is the selected voice for the picker. So the default voice will be voice type. It's going to be alloy. Okay. Next one is the state. Of course, the initial step will be idle. Okay. And also to tell us the debugging, debug letter. Let's also add a bit set in here, which will just print the state, the current state. Okay. And let's also add this idle compute for property, which will basically just using this if case idle state, just return true, else return false. And let's also declare this audio power, which is a double with default value or 0.0. So we will basically listening to the matter in the AV audio recorder, AV audio recorder and AV audio player, which we can use to determine the power of the SiriWaveView. Because that SiriWaveView will just update the animation when we pass the power to the view. It will be between 0 and 1. Okay, now let's navigate to the content view. In here, let's create several previews. So we can preview all the states of our application. The first one is going to be the idle. So let's give it a name of idle. Okay, it will be just the content view. And second one, it's going to be, let me just copy and paste. Second one is going to be recording speech. Okay, for the recording speech is going, let's just declare a ViewModel in here. And in here, let's the content view struct. First, let's declare a state for the wrapper and give it a name of VM and then assign it with the ViewModel as the default value. So basically, we can set the VM state in the recording speech preview, recording speech to recording speech, and then pass this VM when we initialize the content view. And let's make sure to return. Okay, now let's move on to the third state. Third state is going to be processing speech. Let's change the state to processing speech. Okay, fourth one is going to be playing speech. Let's set the state to playing speech. And the last one is going to be error. Okay, let's set the error, set the error, and then just pass this error. And error has occurred. Okay, now we have all 5 previews for each of the state of our application. Okay, if you see here, we can switch between all the previews. Okay, now let's begin. So we're going to begin from the idle and error state because those two will be similar. Okay, so in the body of the content view, let's just remove all of this code in the body. And now let's begin by declaring a vstack with the spacing of 16. Okay, and let's add a padding to all the edges for this vstack. And let's begin by declaring a text and put the title of our application. I'm going to give it a name of XCAAI Voice Assistant. Okay, and set the font to title 2. You can give it any name that you want. Okay, next one, I'm going to use switch vm.state as provide default of empty view. Okay, so for the case of idle and error, I'm going to declare a start capture button. Okay. Now here we can simply declare a start capture button some view. Okay, we should not call this. It should be just our property, right? Okay, now we need to provide the implementation of the start capture button. Let's declare a button, okay, with the action label. So for the action, let's just go to ViewModel quickly and declare a method for now, start capture audio. Okay, it's going to be empty for now. We're going to implement later. Okay, VM start capture audio. When the user click on this button, and for the label view, let's declare a system image with the system name. Let's pass an arrow symbol of mic.circle. Okay, I'm going to change this to idle for the preview so it can be shown. Okay, so this is the button. It's very small. Let's fix this. First, I'm going to set the symbol rendering mode to multicolor. Okay, I'm going to set the font of the system size of 128 so it can be a lot of bigger. And then I'm going to also add the button style modifier for this button to be borderless. Okay, looks very good. Now below this switch statement, let's declare a picker, okay, with the title of select voice. Selection will be a binding of vm.selected voice. And then inside the speaker, let's declare a for each passing voice type dot all cases, because this enum conforms to the case iterable. And then for the ID, let's pass self for the keypad. Then inside the view provider, let's declare this parameter raw value for the text. And for the ID, let's pass the actual parameter, which is the voice type case. Okay, and I want the picker style to be segmented. So let's add a picker style of segmented style. And also let's disable this in case it is not idle. Okay, we don't want the user to change the voice if it is not idle. Okay, so this is the idle state. Continuing on, let's show the error here using if case let error equal to vm.state. Okay, we're going to just show the error.localize description and pass the foreground style of red and set the font to caption, and also let's set the line limit to 2. Okay, so this is the idle state. Now let me change to errors state here. As you can see, the error is being shown. We have the segmented figure and we have the microphone button. Okay, let's go back to the idle. That's it for the idle and the error state implementation. Okay, now let's continue to the recording speech and playing speech, these two cases. In these two cases, we're going to show the SiriWaveView. So there will be basically that form view, waveform view, which we can basically animate using the power property, okay, power state. Okay, let's begin. Let me select the recording speech. Now let's just go to the view model first. I want to add several helper there. So here we already have the audio power to control the wave view. And next one, let's declare this Siri waveform opacity to control the opacity, whether we're going to hide or show the Siri wave view. Okay. So I'm going just to hide it by modifying the opacity to 0. Okay. Here I'm going to use switch state. Not going to use every cases. So for the default, it's going to be 0. This is going to hide the view. So in the case of recording and playing speech, I'm going to return 1 to make it visible. Okay. And let's declare two method also in here. So there will be a button where the user can cancel the recording and also cancel the playing of the audio. Okay, first one is the cancel recording. Let's make this empty for now. And next one is going to be cancel processing task. Okay, now let's go back to the content view and begin the implementation. Okay, the first thing that we are going to do is basically in here. I'm going to move this switch statement in here to a var. I'm going to give a name of overlay view. So we're going to show this as an overlay to the SiriWaveView. Okay, we need to add the view builder to make this work. And next one, we need to import a SiriWaveView. Okay, to access this view. Let's add a spacer in here, spacer, spacer. Okay, and then between this spacer, declare the SiriWaveView. Here we need to add this power modifier, and basically we can pass this audio power. Okay, we will determine the power of the wave that will be shown, and it's also automatically and it will animate automatically as well as we set the new audio power. And let's add the opacity. In here we can just pass the VM Siri waveform opacity that we have just created before. And then I'm going to hardcode the height to be 256. And I'm going to add an overlay. I'm going to pass that overlay view. Now let's also clean this space a bit. Okay, so below this spacer, I'm going to add a vm.state switch statement again below the SiriWaveView. So for this specific case of recording speech, I'm going to declare a cancel recording button, which can be used to cancel the recording. And also for the case of the playing speech, I'm also going to add a cancel button. Okay, playing speech and also processing the speech to OpenAI. Okay, we're going to use a shift task to cancel the async task for this. Now let's declare this cancel recording button and cancel button here. So below the start capture button, let's begin by cancel button. For the cancel button, let's just declare a button with the action label. For the action, let's just invoke cancel processing task. And for the label, let's use fcell symbol again, system name of stop.circle.fill. This will be triggered when shown when we make the connection to the OpenAPI, and also if we currently playing the audio. Okay, let's set the symbol rendering mode to monochrome and set the foreground style to red and set the font to the system size of 44, and let's add the button style of borderless. System size. Okay, need to pass the name of the parameter. Okay, and the next one is the cancel recording button, which will be shown when the user is currently recording the speech. In here we're going to show button destructive. So actually in here I just also want to pass destructive for the cancel button as well. Okay, for the cancel recording button, we can invoke cancel recording from the VM, and let's also set the button style to borderless. And in the label, let's declare image with an extra symbol of xmark.circle.fill. Okay, In here, let's set the symbol rendering mode to multicolor and set the font to the system size of 44. Okay, we have all the buttons in here. Start capture, this one, cancel button, and cancel current button. Let's refresh this. Let's rebuild. Okay, build succeeded. Refresh this. Okay, so if you see here, we have this line, but actually we need to set the power. So for the playing speech, let me set the vm.audio power to 0.3. Wow, this is nice. And for the recording, let's set the audio power to 0.15 or just 0.2. Wow, 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 this is amazing. So this is for the recording speech. We have this button to cancel the recording, and for the play, sorry, this is the playing speech. We have the button to cancel this ongoing speech that's currently being played for the from the AV audio player, and also the recording speech, which we can use to cancel the recording as well using the X button. Okay, so that's it for the recording and playing speech views. Now let's move on to the final state, which is the processing speech. Okay, so for the processing speech, we're going to show an SF symbol, and we are going to animate that SF symbol using the new iOS 17 API for the SF symbol. Okay, so let me select the processing speech preview in here. Currently it's still empty. First, we're going to add a state to control the animation. Okay, state, give it a name of var is symbol animating. Let's provide the default value of false. Okay, okay, we already have this process speech to show the cancel button, and now in the overlay, okay, we're going to show this in the overlay. If the case is processing speech, we're going to show the image with the system name. I'm going to show the brain system name, and basically, wow, this looks very small there in the preview. Let's just use this symbol fact. So this is new. Let's use this one. Okay, for the symbol effect, we're going to use this bounce dot up dot by layer. Okay, so let's bounce the view, make it bigger, smaller, bigger, smaller. And for the options, let's pass repeating. It will keep on repeating. And for the value, we need to pass that state is symbol animating. And next one, let's pass this font with the system size of 128 to make it bigger. Nice. So to make the animation work, we need to add this on appear modifier. We need to basically toggle this is symbol animating to true. It should animate now. Wow, amazing. On disappear. Okay, let's toggle it back to false. Okay, nice. So whenever we make the call to the OpenAI APIs, we're going to show this brand button that will keep on bouncing. Amazing. Nice. And if you see, there's still that cancel button if you want to cancel the processing task. Okay, I think this is all the implementation for the view. Wow, this looks very clean. We have all the previews for the state, from the idle, recording, processing, playing speech as well, and the error. Okay, now we can begin implementing the logic in our view model, which will basically record the speech, making the API calls to OpenAI, and also playing the audio. Okay, now let's go to the view model, and let's begin by declaring several new properties for the view model. Let's begin from the audio player, var audio player. we're going to use this AV audio player. Okay, make this as an implicitly unwrapped optional. Next one is audio recorder, same AV audio recorder. It's going to be also implicitly unwrapped and specific to the visionOS and iOS. So we're going to use this. If not OS is macOS, okay, it will be affecting the visionOS and the iOS if we are using this. We're going to declare this recording session. Okay, I'm going to use this AV audio session dot shared instance. Okay, now let me try to change here to iPhone 15 Pro. Okay, and let me try to build. Okay, the build succeeded, so this is okay. Next one is the timer. We will go having the animation timer. It's going to be optional animation timer. So we're going to set up timer to basically update the power from the AV audio player and recorder for the SiriWaveView, and also the recording timer. Okay. So this timer will be used to basically determine when the user has stopped talking after specific interval. So if you remember, we don't have any explicit stop button for the stop recording. So we're going to use this recording timer to detect whether we show end the recording and send the processing the speech. Okay, you will see that later when we implement this. So audio power, we already have that. Let me move this here. And also we're going to have this pref audio power to also help us on detecting whether we should stop the recording and process it to OpenAI. Okay, so it will be optional double. Next one is a computed property, capture URL. So basically when we record the speech, we're going to store it in a temporary cache directory. So we're going to have this capture URL is computed. We're going to use this file. We're going to use this file manager default URLs for. Okay, it's going to be cache directory in user domain mask. Okay, I'm going to just use first, just first unwrap this, and then appending path component. So this will be the file name recording.m4a. We're going to use the AAC for the recording format. Okay. And next one, let's declare a func to basically help us cleaning the state of our property, reset values. In here, we'll just basically set the audio power to 0, set the ref audio power back to nil, and also for the recorder, we're going to stop and then just set it to nil. So this is just basically to help us clean up all the values when we finish. And to avoid any issue, audio player stop, audio player nil, and recording timer invalidate, recording timer nil, and also animation timer invalidate, animation timer nil. And yeah, I think that's all. So we can use this to reset all the state property in here. And now let's make this view model conform to this AV audio recording recorder delegate and AV audio player delegate. Okay, so there are two methods that we need to override in here. First one is audio recorder with finish recorder. So in case the recorder fails, okay, if the flag is false, then we will basically reset all the values just to make sure, invalidate everything, reset all the states back. Okay, if the flag is false. So if it is true, then we will not process the recording, right, to process the speech to the OpenAI, okay, prompting the GPT4 and generating the speech data, speech audio as well. And next one is the audio player did finish playing. So whenever the audio player finish playing, when the response from the ChatGPT has finished playing, then we will basically reset all the values and set the state to idle. Okay. And also is here, let me just set the state to idle as well. And next one is this cancel recording. So in the cancel recording, if the user explicitly cancel recording by tapping the button, we are also going to reset the values, okay, and set the state back to idle. And now let's move on to the init. We don't have the init yet, but actually let's create the init in here. So this is a nice object. We need to use override init and then call super init. So in the init, so on the macOS, we don't need to use the AV audio session as it's not available. But for the iOS and the visionOS, we need to use the AV audio session to basically initiate the recording session, set it to active, set the category, and also request the audio permission. So let's use this macro. If not OS, macOS. Okay. In this case, I'm going to use this do try catch. Okay, the catch basically just set the state to error, passing the error, and then in the do, I'm going to also add a differentiation in here. If the OS is iOS, and the else if the OS is else, not iOS. Okay, so for iOS, basically we need to use this recording session set category. We need to set the category to basically play and record. Okay, and then we need to pass this option to default to speaker. Otherwise, the audio will be played through the earpiece, right? The earpiece of the iPhone. We don't want that. We don't want to play the audio in the speaker of the iPhone. Okay, so that is for iOS. For the other, which is in this case going to be visionOS, we're going to invoke try recording session stat category to just play and record, and then just use the default one. Okay. Continuing on, let's set the recording session to active by invoking set active passing through. Okay. And we need to request the permission to access the microphone. We need to use this AV audio application request record permission. Okay. The completing handler, let's give a name of allowed. If the allowed it false, if not allowed, let's set the state to basically error recording not allowed by the user. Okay, let's also add this unknown self. Why unknown? Because we will have this instance of ViewModel for the entire lifetime of our application. So we're going to use unknown self. Okay. So we have this request permission when the ViewModel get initialized. Now we can begin implementing the start capture audio. Okay, let's begin implementing the start capture audio. So in here, first, to make sure everything is being reset when you start this process. So this will be the initial state right after the idle. So we're going to just reset everything. And let's set the state to recording speech. Okay, and then let's use this do try catch. So in the catch block, we're going to reset the values as well and set the state to error, passing the error. Okay, so in the do, basically we want to set the initialize the audio recorder. So we're going to use this AV audio recorder using this URL and settings. Okay, for the URL, we're going to use the capture URL from the cache directory. And for the settings, let's pass a dictionary. Okay, first is this AV format ID key. Let's initialize this with an integer of this constant audio format pack for AAC. Okay, it's going to be in pack for AAC format. Next one is the sample rate key. Let's pass this 12,000. Okay, and then the number of channels key. Let's just use one, and then the encode audio quality key. Let's pass AV audio quality dot high dot raw value. Okay, so those are the recording settings that we are going to use. And then, so if you use this impact for AAC, it will automatically compress the audio file, right? So it's not going to be very big when we send that to the OpenAI Whisper API. Continuing on, we're going to set this metering enable so we can monitor the metering, the average power, which we can use to modify the SiriWaveView power. Okay, so let's set it true. Next one, let's set the delegate to self. We already implemented the delegate for the AV audio recorder. Next one is let's begin by just invoking the record. Okay, so it's going to start recording in here. So first now we need to set the animation timer by initializing a timer, repeated timer, using this scale timer with timer interval. So every 0.2 seconds and repeats through. Here we don't need the timer instance. In here we can basically also set the unknown cell. In here we're going to check if the self audio recorder is not nil. Only in that situation we're going to continue. If it's nil, we're just going to return. Okay. In here we can simply invoke self dot audio recorder update matters, so we can get the new power level. So here we need to get the power, so this is going to be a bit tricky, right? So the value for the recording, so as it gets louder, it's going to be the minus value will be get larger. So usually the range when we talk is going to be between minus 30 to minus 50, right? If it gets the volume is getting lower, it's going to be around minus 10 to minus 25. So we need to basically normalize this to a value between 0 and 1, which will can be used for the SiriWaveView. Okay, so just bear with me on this. Okay, let's use this min. Okay, we're going to limit the value between 1 and 0. Okay, then let's add this max. Okay, this one going to be 0. We're going to basically limit the upper and lower bound between 0 and 1. So to convert that minus 10 to minus 50 as the power method get updated as users speak, recording the speech, we're going to use this formula. Okay, so first one I'm going to use 1 minus, and then I'm going to use this absolute to convert the negative value to just positive value, and then I'm going to use double in here. So in this double, I can simply basically invoke this audio recorder and then invoke average power for channel. Okay, for channel it will be 0. Okay, and then I'm going to divide this by 50. Okay, so now the value of this power will be between 0 and 1. Okay, so this is just the formula that I found out and it works, but you maybe find a better formula to calculate the power, so you can try and find the best formula for yourself if you want. Okay, and let's set the audio power to power. This will basically update the SiriWaveView animation. Next one is when should we stop the recording of the timer. We don't want to add an explicit stop button, right? Because if you see lots of other apps, they don't have that stop button where the user need to tap. Right? Even if you try to use the Siri on iOS, it doesn't have an explicit stop button, right? can detect when you stop speaking after specific interval. It will just send the prompt to Siri to process. Okay, so we're going to have a simple, very simple mechanism for that. So for the recording timer, let's also schedule a timer with this timer interval. So every 1.6 seconds, this timer will get executed. We're going to repeat this. And we don't need this timer here. Just also unknown self. Same, if the recorder is not nil, only on that situation, we're going to continue. Else we will return. We also need to update the methods in here. And now, let me copy this power. Okay. So we got the power value, right, between 0 and 1. Now I'm going to check if the self previous audio power is nil. Okay. We're going to assign this previous power to this power and then return. So it will be executed in the next timer. Okay. And then if this got executed, pref audio power won't be nil for the second time. In here, I'm going to check if the pref audio power exists, right? And the pref audio power is less than 0.25, okay? And the current power is less than 0.175, okay? So only in this situation, I'm going to invoke this method, finish capture audio, okay? Let me declare this, finish capture audio. Finish capture audio, okay? And then return. So this will process the audio. If not, I'm going to update the pref audio power again with this power value. Okay, so basically this simple mechanism will just detect if the previous sound is not there. We're going to assign it. Then next time it get invoked after 1.6 seconds again, we check if the previous audio power is less than 0.25 and the current power is less than 0.175. Then we will start processing the audio. Other than that, it will just keep on listening to the user voice, okay, as it keeps going on recording. Okay, so this is the trick. This is a very simple mechanism that I just create, right? So if you find a better approach, I'm sure there will be a better approach, right? This is just a nav implementation. You can update this, okay? So now in the finish capture audio, let's reset the values again. Okay, reset everything back. And let's have this do try catch. Again, in the state, the catch, set the state to error. And then reset the values again. Okay, pretty handy, right? And now in the do here, let's declare a data. And let's use try data contents of, okay, capture URL. So if the data is there, then we're going to, for now, we're going to just play the audio, right? But later we will implement the processing the data to the OpenAI. Okay, this is just for example. Now let's declare this play audio method that accept the data, and this is a throwing function. So in here, we can simply set the state to playing speech. So basically this play audio itself will be at the last of the implementation after we implement the processing speech, okay? But for now, we're going to just the recording and just playing it. And then let's initialize the audio player with the try AV audio player passing the data. And then also set the mattering enable to true. And let's set the delegate to self. If you do player delegate, we have already implemented that. And then let's set the audio player to play. Okay, so it's going to play the audio. We also need to update the waveform, right, as we play the audio with the power. So I'm going to basically copy and paste this animation timer to here. But remember, don't use this audio recorder, right? We need to use audio player, and audio player. Okay. And for the power, we need to change this to 160. Okay. So this is the value that I get when I test this. As we play the audio, as it got larger, the value will be around 140 to 160. Okay. So we need to normalize this using 160. Okay, so that's the implementation for this. We need to test this recording for now. So to test the recording of the microphone, I recommend you to use an actual device, whether it's an iPhone. And for Mac, you can just use your MacBook, right? So let's just change the scheme to my Mac to test this. Okay, let's build. Okay, build succeeded. Now let me move this window. So this is the app. So let me click this. Okay, it's going to add this permission window. Let's provide the permission. Talk with AI assistant. Okay. Hey, what are you doing? Hey, what are you doing? Nice. It record and play the audio, right? So it works. Now we are sure the recording works. Now let's implement the processing part to the OpenAI APIs. Okay, let's stop the process. Okay, and now we'll need to declare one property to hold the ongoing task. We're going to basically use Swift concurrency, the new Swift concurrency to hold the task. So in here, okay, let's declare this processing speech task. Okay, so make it task with void and never. Okay, so let's make this also optional. And now scroll down below the finish capture audio. Declare a new func process speech task. Okay, that accept audio data and return this task void and never. And in here, in the finish capture audio, let's make sure to replace this as the name processing speech task. So this is the var. Let's then invoke this process speech task passing the audio data. Okay, now let's begin implement this process speech task. So we're going to basically create a detached task that run in the main actor. So let's use this task, and to make sure this is running main actor, let's use this main actor in. Okay, let's also declare this unknown self. Now let's begin. So we need to use the main actor, otherwise whenever we update the UI inside this task, it will probably cause an issue if not we are not using executing this in main actor. Okay, so do catch again in here. In the catch, always we're going to make sure we set the state to error, and then basically also reset the values. But remember, this is a task which is cancelable. Okay, this task can be canceled by if the user tap on that cancel button, right? So here, the task, we're going to check if task is canceled. So this will be invoked, right? We just return. We don't want to set the state, otherwise it will cause inconsistency, right? The task is canceled by user. We're going to basically set the state to idle manually later. The in this cancel processing task method. Okay. Actually, let's do it now before I forgot. Okay. So cancel processing task should be invoked when the user tap on the button, cancel button. We're going to cancel this. Okay, and set the value to nil. And we're going to reset the values and set the state to So if we cancel this, it's going to cancel this process speech task. Okay, now let's begin implementing the do. The do, basically, let's set the state to processing speech. Okay, so now let's declare the prompt. So basically, we need to convert this audio data to text prompt. So we can use this try await client generate audio transcription. Okay, for the audio data, let's pass the audio data. Okay, continuing on, after we get the prompt speech that has been converted to the text, we can check, right, whether the task has been canceled. Okay, if it's canceled, it's going to be throwing, and then in the catch, it's going to just return. Okay, and then now continuing on, we need to basically prompt GPT-4 using this prompt text. We're going to use this try await client from ChatGPT. So if you see, there are several parameters such as model, assistant prompt, and previous message. But for us, we're going to just the prompt, pass the text prompt, and then for the model, we're going to use the default model. It's going to be GPT-4. Assistant prompt is going to be you are a helpful assistant, and we're not going to pass the array of previous message. But if you want, you can, right? So it can aware of the previous conversation, but you need to manage the array by yourself and also manage the number of message that you pass, because you cannot pass too many tokens to the GPT API, right? Okay. But for simplicity, the simplicity of this tutorial, I'm just going to pass the prompt and the model and use the default model. Okay. For the prompt ChatGPT, just pass the prompt from the Whisper API in here. So after we got the response back from ChatGPT, we need to convert it to audio now. But so after we got the response text from ChatGPT, we need to convert to the speech audio. But before doing that, we're going to check the task has been canceled by the user. Okay, if it is canceled, then it will just return. Okay. Now let data and then use try await and then info client generate speech from. Okay. Here we can just pass the input string, the text that is going to be converted to audio. And here we're going to also pass the voice. Okay. So for the voice, we can basically use this init raw value. For the value, we can use this selected voice. If it is failing to initialize, we just use the alloy as the default value. Okay. So if you encounter an error, you need to basically build this app so it can work. Okay. So I need to pass raw value in here. Okay, now it works. So we got the audio data, and now again we check if the task has been canceled. We just return, right? We don't want to continue. So after we got this, finally we can just invoke the method that we created before, play audio, passing the data from the TTS API. Wow, this looks amazing, right? And now, if you're wondering when will be the state will be get idled back, remember that we already implement this audio player that finished playing. So if it finished playing, it will be going to reset the values and set the state back to idle. Now we can try this. So let's try this. I think this will work. So let me use this Onyx as the voice. What is a transistor? Oh, nice. Let's wait a bit. So how long it is, it depends on the how much larger the data that you send, and also the response from the GPT-4 itself.
A transistor is a fundamental component in most electronic
This
devices.
is nice, man.
It's a semiconductor device that can amplify or switch electrical signals and power. Used primarily in computing and signal processing, it is the key ingredient of most electronic
Nice.
circuits.
Now let's stop this. Wow, everything works, right? So remember that we can also cancel this, and yeah, that's basically For that, I'm not going to demo the Apple Vision Pro and iOS again. I've shown the demo for those at the beginning of this video. So that concludes our tutorial. We have built the front end SwiftUI app for the AI voice assistant. For our backend, we utilize the OpenAI API for the GPT4 large language model, Whisper API to convert the audio speech to text, and also the new TTS API to convert the text to speech. And we can also customize the voice that will be generated. So that's it for this video. Love the video if you like, subscribe if you haven't, and thanks for supporting me, and see you in the next one. Let's keep on being a lifelong learner.